Well, in today's homework video, we're going to focus on 3D shapes. So I want to introduce you to a number of those and talk about how you can identify 3D shapes or put them into groups or categories. All right, so let's start with a couple of basic 3D shapes. Let's start with these ones. We have a shape here that we call three-dimensional because it won't just fold up like a 2D shape and slide into a book and close and you wouldn't even know it's there. That's what a 2D shape does. But a 3D shape has depth as well. And we define a 3D shape based on its edges, the number of edges, the vertices, which was a word that you learned in Miss Chilton's video the other day, vertices, all right, and also the faces. So they all have them. We've got edges, okay, vertices, all these corners are vertices. It's where your faces meet, okay? And so these are our faces. So let's look at another one. Edge, face, any vertices? No. So let's start with counting a few edges and vertices and faces. Let's look at this one first. This is called a prism, and so is this. And so is this. Let's see what they all have in common and why they're called prisms. Well, first of all, they all have edges, vertices, and faces. Okay, have a look. Edges, vertices, and faces. And so does this one. Edges, vertices, and faces. Now, they're all called prisms because both bases or the bottoms of these shapes are parallel to each other. Okay, so if we have a look at this prism, we could call this a base, and this is also a base, or it could be the top, okay, like this. And they're parallel, they're the same direction, they're parallel to each other. And so therefore they are prisms. Now let's count the faces first. We've got 1, 2, 3, 4, 5, and don't forget at the back, 6. So this has 6 faces. So does this one. 1, 2, 3, 4, 5, and the one at the back, 6. So these both have 6 faces. What makes them different? One is just larger than another. Let's check the vertices on this one. 1, 2, 3, 4, 5, 6, 7, 8. 8 vertices. Same with this one. Let's check the edges. So I'm going to start with our base. When you put it down, this would be our base. Okay? 1, 2, 3, 4. And then let's flip it and do this side now. 5, 6, 7, 8. Now we have to go around it. So I'm going to turn it so you can see. 9, 10, 11, 12. It has 12 edges. So does this one. These are both rectangular prisms. All right? Now remember I told you if we were to place it like this, we've got a base here, and this could be the top or the base as well if I flipped it over. Okay? So when we look at these bases, they're parallel to each other. They run the same direction. So it's a prism. Okay, a prism. And let's count the faces. 1, 2, 3, 4, 5. 5 faces on this one. Okay, and let's count the edges. 1, 2, 3, 4, 5, 6, and then the other base, 7, 8, 9 edges. This is not the same as a rectangular prism, because if you look at the base, it's a triangular shape, isn't it? So this figure is called a triangular based prism, a triangle prism, okay? Rectangle prism, triangle prism, because our bases are parallel to each other, and that's the shape of the base. All right, let's have a look at another one. This one. This is also a prism, but we call it a cube, okay? We could say that this is a square prism, square-based prism, because the bottom is square on it, and all the sides are square, but we generally just call this a cube. So we have a cube here. Let's look at this one. How is this shape different than this shape? We should say figure, because 3D aren't shapes, they're called figures. So how is this figure different than this figure? Well, if you look, all the faces in this figure come together and meet at one vertice. And so we don't call it a prism. If all the faces come together and meet at one vertice, we call this a pyramid. And I have two pyramids to share with you right now. So look at this one. And look at this one. When you look at this pyramid, you'll notice that all the faces, okay, come up to form one point. Just like this one, the faces on the sides of the figure come up to make one point. Do the faces all come up to make one point or one vertice on a prism? No, they don't. Okay, so that's the difference between a prism and a pyramid. I'm holding it, all right, and its base is touching my hand. Look at the shape. What shape is that? It's a square. And so we call this a square-based pyramid. This figure is a square-based pyramid. Let's look at the number of faces that it has. 1, 2, 3, 4, 5. Okay, it has 5 faces. And we could count the vertices. 1, 2, 3, 4, 5 vertices. And let's count our edges. 1, 2, 3, 4. 4 edges go around it. And then 5, 6, 7, 8. 8 edges on this square-based pyramid. Okay, let's look at this pyramid. Here's sitting on my hand, so this is considered the base. What shape is it? It's a triangle. So what do you think we call this one? It's a triangular based pyramid. All right, triangular based pyramid. So because we define our pyramids based on the shape of the base. So we've just tackled pyramids and prisms. All right. So here's a skill testing question for you. What's the difference between a prism and a pyramid? Let's look at a few more shapes. I'm going to introduce you to another prism. Here it is. The bases are parallel to each other. Okay. And what shape is this? 1, 2, 3, 4, 5, 6. What do we call that? We call it a hexagon. So this is a hexagon prism. Okay? And you'll notice that the sides are all rectangles, just like this one is a rectangle. Or this one is a rectangle. Okay? So we've got a hexagon-based prism, or a hexagonal prism here. And we can count the vertices on both ends. We can count the edges on both ends and around here. And we can, of course, count all our faces, the flat surfaces. Okay? So what else do we have here? We have you see this? You see it on a paper towel roll. You can see it on pipes. It's a cylinder. It has two round ends, or circular ends, and it has an edge here and an edge here. Does it have any vertices? Nope, it doesn't have any vertices. Okay, and so we say that it has a curved surface here, and it has a circular surface face here and here, a cylinder. My favorite, yum, 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 great ice cream. Let's look at the cone itself. That's exactly what it's called. It's a cone. We have another circular base, because this is how it would stand, a circular base. We have a curved surface and one face that's circular. And does it have any vertices? As long as your face curved surface comes to a point, we call this a vertex, 1 point. It doesn't have more than one. So if it was 3 points that it came to, then we would say it has 3 vertices. In this case, it comes to 1 point, which is the vertex. Okay? And lastly, we have our sphere. It's one curved surface. There are no separate faces like we would have in a square-based pyramid. So it's just one big curved surface. All right? One surface or face all the way around. No edges, no vertices. And that's our sphere. It has an F sound, sphere. Okay, not sapphire, sphere. Now that we've been able to identify all our shapes, and you need to know the names of these shapes, then we can start organizing them or categorizing them based on the number of faces, or the number of edges, or the number of vertices. We can also categorize them based on whether they're pyramids or prisms. So there's lots of ways we can group and organize our 3D figures, and that's what we're going to work on in the next little while. See you tomorrow.